Hello everyone, welcome to our PySpark interview series. In this video, we're diving into one of the most fundamental questions: what is PySpark and how does it differ from Apache Spark? If you're preparing for a PySpark interview or just getting started, this is the perfect place to begin. We'll break it down in simple terms so you can confidently explain the difference in your next interview. Let's get started. Definition: PySpark is the Python interface for Apache Spark, making it possible for Python developers to leverage the powerful distributed computing capabilities of Spark using Python. Essentially, PySpark allows you to work with Spark's framework, which is designed to process large-scale data efficiently across clusters of computers. Apache Spark, on its own, is an open source system that excels at quickly handling vast amounts of data by dividing tasks across multiple machines, making it ideal for big data applications. With PySpark, Python users can tap into this power without needing to switch to Scala or Java, making it easier to work with data at scale while staying within the Python ecosystem. PySpark is essentially the bridge that connects Python to Apache Spark. It's the Python API for Apache Spark, which allows developers to use the Python programming language to work with Spark's powerful distributed computing framework. What does that mean? Basically, it lets Python users take advantage of Spark's ability to process large amounts of data quickly and efficiently across multiple machines without having to learn another language. So if you're comfortable with Python, PySpark makes it easy for you to harness the speed and scalability of Spark for handling big data tasks. Difference between Apache Spark and PySpark. Let's break down the key differences between Apache Spark and PySpark feature by feature. Language support: Apache Spark supports multiple languages including Scala, Java, Python, and R, allowing developers from various backgrounds to use the framework. PySpark, however, is specifically designed for Python developers. So if you're comfortable coding in Python, PySpark makes Spark's distributed computing capabilities accessible to you without needing to learn Scala or Java. For example, if you're familiar with Pandas, you can use PySpark's DataFrame API in much the same way to manipulate large datasets across multiple machines. Core language Apache Spark itself is written in Scala, which is highly optimized for performance. This is why Spark natively runs faster in Scala and Java environments. PySpark, while written in Python, leverages Spark's underlying engine for distributed data processing, meaning you get the power of Spark but with the ease of Python. For example, you can perform operations like filtering, joining, and aggregating data in PySpark, and Spark handles the parallel execution under the hood, making it suitable for big data processing. Performance: when performance is critical, Apache Spark is often faster when used with Scala or Java because these languages compile to JVM bytecode which Spark executes directly. PySpark, on the other hand, incurs a bit of overhead because Python has to interact with the JVM. For example, in a high performance real-time analytics system, using Scala with Spark would likely provide better performance compared to PySpark due to Python's relatively slower execution. API compatibility: Apache Spark has full API support for Scala and Java, meaning every feature of Spark is available in these languages. PySpark provides nearly full API compatibility, but some advanced APIs, particularly those around low-level operations, might not be as fully featured in Python. However, for most data engineering and data science tasks, PySpark's APIs are more than sufficient. For example, PySpark has a data frame API similar to Pandas, allowing you to perform SQL-like operations such as select, filter, and groupie. Ease of use: Apache Spark can be more complex, especially when working with Scala or Java, as these languages are more verbose and follow functional programming paradigms. PySpark, however, makes working with Spark easier for Python developers thanks to its simple, readable syntax. For example, instead of writing complex Scala code to load and filter data from a CSV file, community Apache Spark has been around longer and has a large established community, especially in Scala, given that Spark is written in Scala. However, PySpark has a rapidly growing community, particularly among Python users in the data science and machine learning fields. This means you can easily find resources, tutorials, and community support for both, but PySpark's community is expanding due to Python's widespread use in data science libraries and tools. Apache Spark supports all of Spark's native libraries like Malib for machine learning, Spark streaming, and graphics. PySpark integrates with most of the Spark libraries, but it also offers something unique for Python developers: compatibility with popular Python libraries like Pandas, NumPy, and scikit-learn. This allows you to use familiar Python tools alongside Spark's distributed computing capabilities. For instance, you can pre-process data using Pandas and then scale your processing using PySpark for larger data sets. Integration: Apache Spark integrates well with Scala and Java ecosystems, making it a strong choice for organizations heavily using these languages. PySpark, on the other hand, is ideal for Python based ecosystems, which are common in data science and machine learning environments. For example, PySpark can easily integrate with Jupyter notebooks, allowing data scientists to write distributed data processing code within their familiar environment and analyze results interactively. Syntax: the syntax in Apache Spark, particularly when using Scala, can follow a functional programming style, which can be more difficult to grasp if you're not already familiar with it. For example, map reduce operations in Scala look quite different from the procedural style many developers are used to. PySpark, however, provides a much more Pythonic syntax, making it easier to work with, especially for beginners. Instead of writing complex function chains in Scala, you can use simple, readable code in PySpark like this. Use case: Apache Spark is often used in scenarios where performance is critical, such as real time data processing, large scale data analytics, or ETL pipelines running in Scala or Java. For example, financial services or e commerce companies may use Spark in Scala to process billions of transactions in real time. On the other hand, PySpark is preferred for use cases where ease of use and quick integration with Python libraries are important. It's widely used in data science and machine learning projects where you need to process large data sets, train models, and analyze results. PySpark simplifies this workflow by allowing Python developers to scale their Python based solutions with Spark's distributed computing. And that's a wrap for today's video on PySpark vs Apache Spark. We hope this explanation gave you a clear understanding of the two and their differences. Stay tuned for more must know PySpark interview questions coming up in this series. If you found this helpful, don't forget to like, subscribe, and hit the bell icon for updates. See you in the next video.